To draw the correct Lewis structure for the phosphate ion here, we first got to determine the total number of valence electrons. And phosphorus has got 5. Each of the 4 oxygens has got 6 for 24 more. That's 29 total. And then a -3 charge means 3 extra electrons for a grand total of 32 valence electrons. So it turns out every single one of these has got 32 electrons showing, so that's not going to be the most helpful thing in the world in this case for eliminating wrong answer choices. But one thing is we do know that this has a total -3 charge, and therefore the formal charges have to add up to -3, and the formal charges are shown here. So this one is shown without formal charges. That's not going to add up to -3. This one would total out at -1. This one would total out at -2, not -3. We'll get rid of both of those. But both of these should total out at -3. In this case, though, this one, you can see this oxygen here has 10 electrons around it. That violates the octet rule. Oxygen being in the second row is not allowed to go over the octet rule. It's only third row and lower that's allowed to. And so we could get rid of this choice. And so without even drawing this, we can narrow down all the wrong answer choices. But let's draw this proper. First thing we'll do is set up the skeleton. And phosphorus can make the most bonds, so he goes in the middle. And we set up single bonds to all the outside atoms. And from here, fill up the octets of all the outside atoms. You will always have enough electrons to fill up all the outside atoms, so just kind of do it without taking an accounting. Alright, from here, any remaining valence electrons go on the central atom. So in this case, 32 electrons, well, we've got 32 on the board. There's no remaining electrons to go on that phosphorus. And then once all electrons are used, form multiple bonds to the central atom if not full. So in this case, the phosphorus does have a filled octet. But one little last rule that's not for most compounds here is we're going to look at formal charges. And in this case, oxygen normally has 6 valence electrons, and here he's got 1, 2, 3, 4, 5, 6, 7. And 6 minus 7 is -1. Same thing for all the oxygens. Cool, and for phosphorus, phosphorus normally has 5 valence electrons. Here he's got 1, 2, 3, 4. 5 minus 4 is +1. And so in this case, if you have opposite formal charges for atoms that are attached, you can actually have the -1 take a lone pair and put it into a multiple bond. And that's going to result in decreasing the overall number of formal charges in the molecule, which is preferred. And so in this case, if I make a double bond with one of the oxygens here, and it's arbitrary which one, we can actually draw 4 resonance structures for this thing. But now we're still going to have 3 oxygens with a negative formal charge. But the phosphorus and the oxygen on the right here no longer have a formal charge. And like I said, there's actually 4 different structures we can draw. That's just the first one. And notice the question actually asks for which of the following is a correct Lewis dot structure, because there's 4 of them that we'd actually draw out, and we'd put resonance and put the -3 charge over here. And this guy's one of them. Your double bond could be with any of the oxygens. Here it's with the one on the left. But that is one of the correct Lewis structures. There were 4 possibilities.